So, hello and welcome to our presentation of today. Thank you for the nice introduction. So we will present on ZigBee-based smart homes and what hackers can do actually with these kind of smart homes. So let me first introduce ourselves. My name is Tobias. I work as Senior Information Systems Auditor at a security company called Cognosec in Vienna. I do most of the time penetration testing, any kind of security audits and consulting in this area. And I also do some kind of IoT research project during my work time, also my spare time. And I like to play with software-defined radio, because I think it's a very exciting new technology and new opportunities arise in the research field there. I'm also owner of a ZigBee-based home automation system. That's why I chose to do some research on ZigBee. Today with me is my colleague Florian. So he works also at Cognosec in Vienna, in the same department. And yeah, in his free time he's archaeologist, so it's a little bit not the traditional way of IT. What do we want to cover now? At first, I want to give you a short introduction. What is ZigBee? In which areas is it used? Not only for smart homes, as we will learn today. I will present you my journey I made during the ZigBee research. This means, at first, I looked into the standard, discovered a lot of security measures in there. Then it took a little deeper dive, and it got worse. And then we tested some devices. We brought them today. And the implementations are really, really ugly and really mess. And at the end, we plan to do a live demonstration, but we have video backup because it's a little bit, demo. Yeah. So what it's all about? ZigBee and smart homes. I built at my place a smart home system and use ZigBee because it's one of the most popular smart home protocols at the moment, and it's also wireless, so I don't need any cables. A lot of vendors support ZigBee. There are a lot of certified products out there, and it's open, so I can actually look into the standard, and there is no fee for getting the specification. So ZigBee is a wireless standard, especially designed for low-cost, low-power devices. It's based on IEEE 802.15.4. So ZigBee is actually residing on the network and the application layer. So this means there are 4 layers: a physical MAC layer, which is covered in the IEEE standard, and ZigBee is implementing a network and an application layer on top of that. ZigBee is a two-way. This means messages get acknowledged and is considered as a very reliable option in this field. So it is not only used for smart homes. It's also used in remote control, healthcare, retail services, smart energy, but I want to especially mention smart energy is different than smart homes in this area. People created the smart energy ZigBee profile, put a little more effort in thinking about security. What else is interesting for ZigBee? So it's also on the rise. So the NASA launched a rocket beginning of this year, and it also contains ZigBee sensors for measuring temperature and pressure, and so the parachute is actually controlled using ZigBee devices. This means it's not only a theoretical topic, so it gets really used also in industry and high-cost applications. ZigBee is developed by the ZigBee Alliance. This is just some logos from the homepage. You see there are really the big players are involved in ZigBee. So it's very popular, and there are big companies behind it. They will drive the evolution of the kind of stuff. So why it is important? So why do I want to talk about especially ZigBee and wireless smart homes? So it is expected that till 2020, the amount of devices, IoT devices, will rise to 26 billion. And it's a Gartner prediction, but over 500 smart devices per household should be there in 2022. Yeah, it's Gartner, but even if it's 100 or 50, it's a huge amount, and it's So you need to have wireless communication. Wired wouldn't be an option, in my opinion, because that won't work. Also, the Samsung CEO made a really interesting announcement at the beginning of this year. He said every Samsung device will be part of the IoT till 2019. So the development is on the rise. Also, to another example of how ZigBee is used in the real world. In August this year, some guys in Austin in the US made a really interesting project. So they built a drone with a ZigBee scanning device. So the drone is flying over Austin, and they are scanning for ZigBee devices on a range of 100 meters, I think. So you can look it up on this link. It's very interesting. You can see in a live way where the drone is, what ZigBee devices are out there. This is a short summary of the project statistics. They detected this one was of the first runs. It was a 20 minutes flight, and they detected this amount of ZigBee-enabled devices. This means it's 1,500 roundabout. So in 20 minutes, that's a huge amount, in my opinion. And you also see there is not only one vendor. This is a list of what vendors they found producing the ZigBee devices. So it's a very diverse field, but you can see, for example, Philips has a high amount. It's the Philips Hue system. Also Sony or Control 4 is the very common smart home devices are popular there. That's also a picture of the map. So you see there are really a lot of ZigBee devices out there. So that's it. Why do we need security in this field? So for me, home automation includes the word home. Home has for me high privacy requirements. The home automation is a huge source of personalized data, and there is a high interest in it, not only by some random external attackers. I brought today a quote from the former CIA director David Petraeus. Items of interest will be located, identified, monitored, and remotely controlled through radio technologies, through technologies such as radio frequency identification, sensor networks, tiny embedded servers, and energy harvesters, all connected to the next generation internet. So the next generation internet in this relation is the IoT. So that's exactly what ZigBee is. So there is an interest in it. So now the good. When you look, when you take a first look at the standard, you will find some really nice security measures. So they thought about it, you think. So they are applying symmetric encryption using AES and CCM mode with a 128-bit key. They apply integrity protection up to 128-bit, and they also introduced replay protection. It's a 4-byte frame counter, which is actually, for the purpose of the devices, it's okay. So you think, okay, they thought about it. They also put a very nice statement in or recommendation in the specification. So all of the security features should be developed and tested by security experts. But as we will learn later on, there are not so much security experts obviously out there. So what else is interesting? ZigBee security. So ZigBee provides 7 different security layers, security levels. This means you can apply a lot of combination about what kind of MIC I want to provide, how long, what kind of key length. So there are 7 different levels, but you can only apply one security level per network, which means that your lowest security capable device will determine the security level of your network. This means, for example, a light switch. There are light switches out there using ZigBee that don't even have a battery. This means they press the energy for sending the radio commands just by pressing the button, so they turn mechanical energy into the radio command then. The security is just based on symmetric encryption, so the keys are really important for that. They have 2 different kind of keys. On network level, a network key, and on application level, They call it link keys. This means it's a device-to-device key. So when you compromise the network level, in theory, you are just able to listen to some also encrypted communication then. But we will see. Yeah. That's also from the standard. So they really highlight that it's very important and only reliant on the secrecy of the keys. So it's secure initialization, secure installation, secure processing, and also secure storage of the keys. Today I want to show you then secure initialization and processing of the keys and also installation. So because storage was covered by a security researcher called Travis Goodspeed, he took a couple of ZigBee devices and extracted the key material out there, which is not very surprising because as mentioned in the beginning, it's a low-cost, low-power devices, so they are not tamper-resistant at all. You can just grab the keys. But for this, you need physical access. So keys are really important in the secrecy of keys. But how do the keys get to your device? So the standard specifies 3 different ways. This means you can pre-install it at the factory. You can do an out-of-band key transfer, out-of-band recommended. So this means you're using wireless communication, so don't exchange the key wireless. Do it maybe using a cable or type a key in. There are many options of doing this. And key establishment. But key establishment, so you need also pre-installed keys because the keys are derived from so-called master keys. So in the end, in my opinion, there are 2 options. You pre-install it or you do a key transport. All devices I know, and we tested, and I talked to really a lot of people in this field, are just doing an in-band key transport. So where it gets bad then, beside from the security measures provided, are then application profiles. So application profiles define how ZigBee devices communicate to each other, so they enable them to agree on message formats, what processing has to be done after receiving a certain action. Yeah. So they enable them to be compatible and interoperability. Yeah. So what is very important there are the startup attribute sets. So this means every ZigBee device has some kind of a default configuration when at startup. And these startup attributes are very interesting. For example, for the home automation profile, I took 2, or the 2 most security relevant startup attributes. The first one is default trust center link key. This means in the past, ZigBee exchanged the key without encryption in plain text. So some researcher told them that this is not the best way, so they implemented an encrypted key exchange. But they also defined a default key for devices that don't know each other, which is okay for some reasons. But in combination with the second attribute, the default link key join, so they require you to support this kind of encryption as a fallback. So this means every ZigBee device, which is certified, has to support a key exchange using the publicly known key. So my first thoughts were, okay, maybe I can jam some kind of communication to trigger the devices to a fallback key exchange. But it turns out you don't need to do this because all of the devices just using this fallback because they have an agreed method of exchanging keys. Why should they put additional effort in? And they are compliant to the standard. So yeah, very frustrating from security perspective. They have, for example, another application profile is the Lightlink profile. Philips Hue is using this profile. It's using a different approach of security, security by obscurity, when we name it. So they agree that they will use a secret key, not the publicly known, like in the home automation key. They agree they use a secret key for encrypting this, the actual network key. So, and this key is only delivered to certain manufacturers, and they have to sign contracts, and they will really keep it secret, but this doesn't work. History told us. So if you look it up on Google, you will find some posts by a guy called Maya ZigBee, I had the honor to meet him in person, and it's really funny because it's a constant chase. He puts posts on the internet, and then they get deleted because the ZigBee Alliance wants to keep the key safe or secret, yeah, and deletes all the time his messages. So it's a constant battle, posting it, deleting it. In addition to that, the Lightlink profile also specifies a trust center link key. This means a Lightlink profile device is compatible to home automation devices. So they also support the default key, the default trust center link key, and the insecure join. And they have a third very interesting attribute called network all fresh, which means do not check the frame counter. The frame counter is for replay protection. So there is a high chance that Lightlink certified products are vulnerable to replay. So to really point it out, the home automation profile requires you to support a known encryption key as fallback, which means in practically this is the same security level as doing a plain text key exchange. And the ZigBee Lightlink profile uses a secret but known key for protecting these key exchanges. So they are vulnerable. The next step we took is we looked at real-world implementations and tried to validate our research and look how it's really implemented in the real world, and do they all really just only rely on the fallbacks. So during the research on implementations, I came across a ZigBee open source stack, CBOS, and there is a interesting service in there. The ZigBee specification is talking about the request key service. So a device can call the central ZigBee router, what is the actual network key? So they call it request key. I don't get it, why you would need such kind of service, because when you apply network encryption, the device will only accept encrypted messages. So this means you need to know the network key to create a valid command there. And if you are not using an encrypted network, there is no network key. So I don't get it why you should do such kind of service. And I'm not the only one that doesn't get it, because I looked it then up in some kind of comments, and the developer also stated there, he doesn't know what to do when receiving this command. Should he send the current network key? Should he send the previous network key? Should he send it encrypted or not unencrypted? It's not clear. So the specification is very blurry in this point. So what the ZigBee open source stack is doing, he initiates unsecured key transfer, so he sends it in plain text, which doesn't really make sense. Back to the first comment, it's also really interesting is application keys are not implemented. This means then the security level is only based on the network key, and there are no device-to-device keys possible using this version of the ZigBee open source stack. So we tested then a lot of different products, like the door lock we have there from Yale, a popular smart home system, SmartThings, which I also use at home, and some light bulbs for better visibility, Philips Hue and Osram Lightify. So the results were very interesting because they all use just the default trust center link key for the initial key exchange, and they don't support link keys, so they don't support encryption application level. So this means when you get the network key, you get you compromise the whole network. There are no security configuration possibilities. This means I can't change the network key. This means if it's compromised, you have to throw the devices away. Because there is also no key rotation applied. We tested the test period 14 months now. There is no key rotation. So, which makes it very hard because you can't reset the devices also. So the smart sync system, you are not able to reset it. There is not even a hardware reset button. So compromised, you can throw it away. And light bulbs also, they don't require physical interaction for pairing, so they are constantly looking for devices to pair which is also very, very nasty, because if you're, for example, if your neighbor also has the Philips Hue system, you can just steal his light bulbs and switch on the light off and on. Just, yeah, for in the bedroom, it would be not so nice. So. This is also then very funny, because they are aware of this problem, and they put a little workaround in there. So when you start, for example, at your Philips Hue system, a search for light bulbs to join, the transmission power is very limited, because otherwise you will always get the light bulbs from your neighbor and steal it constantly. So you have to be very, very close to when you pair unknown light bulbs to your system. This means in the real world, we were running, you need a power plug and an Ethernet connection for this. So you're going then up there and with your Philips Hue system and connected devices. So this means on the first look, you think, okay, there is something wrong in the design. So this shouldn't be this way. There should be another way of doing this. Okay. Then we're now at the funny part. We developed also a tool for security testing. So we call it ZigBee, secure ZigBee. And we wanted to build a tool for enabling security auditors testing ZigBee implementation. And also we had in mind such kind of to enable developers to do a quick check of the security critical implementations in the ZigBee stack. This means they're just like an automated vulnerability scanner for ZigBee. Yeah. We are using the USP as software-defined radio, because it's a very powerful device, and we are also using the Raspberry Pi with extension board called Raspberry for ZigBee communication. We will get to this while we're using two devices there. On the software layer, the tool is based on ZigBee radio and KillerBee and Miracoli. On top of that, we built now then our own functions. We implemented encryption, because encryption was not available or is not integrated in KillerBee. And we noticed all modern ZigBee implementations are using encrypted communication. So at the moment, we are providing some kind of really nice features. So we support encrypted communication. We can do command injection. We scan constantly for this weak key transport and take the keys and store it in our device. There are also some nice features like reset the factory commands. We can reset light bulbs. We can join to new networks, and we can do it all in an automated way. So why are we using two devices? ZigBee has two different ways of communicating from coordinator to end device, which means from router to end device. And they call it direct and indirect. So we struggled a long time, because in theory it should work, but we didn't get what was the problem, why our demo doesn't work. So in the real world, there are ZigBee devices with power supply, which means the ZigBee router. The receiver is on all the time, so you can send all the time messages there. That's called a direct data transfer. This means just send your data there, you get an acknowledge, and you need, okay, received, very good. But as we heard, ZigBee is built for low power devices. This means, for example, the door lock we have is just battery powered. And to save battery power, the receiver is off most of the time and just wakes up in every 5 seconds and checks at the router, is there data available for me? This means the end device sends so-called data requests and waits for an acknowledge, and in the acknowledge there is a flag set if a frame is pending for this device or not. So if he gets an acknowledge, there is no data, goes instantly to sleep, and you can't send him data. So, and the problem is, it's a very small time frame. It's 0.8 milliseconds. You have to send the acknowledge, and since I am not the best programmer, it might be that my USP implementation is too slow. So it's 10 times too slow, because it goes from radio signal demodulation to on C level, then to Python. I do some work on the packet, and then it goes again Python, C, and then it gets sent using the USRP. On the Raspberry, we have the advantage, it's much faster, so it does automatically acknowledging. So we are using the Raspberry for doing acknowledging and sending then the data to, or doing the indirect data transfer, and the direct data transfer we are using, we are doing on the USRP. So now it gets interesting. We are doing then, we try to do key extraction. This means we know the fallback key exchange is insecure. Most vendors implement only a fallback solution, and yeah, it's the same security level as plaintext key exchange. So first I want to show you a video about just the simple sniffing of this kind. So that's basically the same as our live test setup. So we have our door lock. This is our smart sync system. It's the USB, the Raspberry. It's our test laptop where the ZigBee tool is running. And in the middle, that's the SmartThings mobile application. So I put searching for new devices. And I also put the door lock into joining mode. So you see on the left there is some debug output, and the devices got joined. We will see this later on in a more detailed way, but just to show you, we are able to extract the key when these kind of devices just do the normal traditional pairing. So we took this and went to the vendors and also to the ZigBee Alliance and said, okay, this might be a problem because everybody is required to just do this kind of stuff, and nobody tells the end user, okay, be aware of when you first initialize your pairing, make sure nobody is close around you and does this, yeah. But they said that's absolutely no problem because the time frame is very, very limited. That's true. The time frame is limited. You have to exactly get the right packets. But there are some ways you can trigger a key exchange. For example, you can jam radio communication. Every typical end user is trained to do, if your wireless device loses connection, just do a repair. If your Bluetooth keyboard doesn't work anymore, do a repair. So we just jam the communication and wait for the users to repair the device. This is an option, but not the best stuff. So we looked at another way to trigger the key transport and sniff it, and we found one. So that's now the tricky part. We need, I forgot that we need this picture on the beamer. Yeah. The display from the laptop.
Ja, genau so.
Best setup ever. Was hat's denn? Ja. Yeah. No. So on the laptop is the ZigBee tool running, and what I just want to show you is then the real output of the device in a human readable size of text. So yeah, that's the typical problem of demos. Yeah, that's the. Okay. Why? A moment. Hotfix. Don't be nervous. So now we have back. Can you make it full screen on the other side? So basically, what was the problem? Our tool is constantly sniffing for device communication and makes a list of what devices are out there. And since we didn't trigger any communication between the door lock and the router, it only found one device, the router, so we had to issue a sort of communication that also the door lock is in our source list. Yeah. So. So, load it. Save and load again. Yeah. Da? Okay. Obviously, the tool is not designed for multi-display because the file menu comes here. Yeah. Okay. It's a feature. Maybe we can do it later on in a more controlled way. So. So what we would have seen is that there is a special command. It's called rejoin. So if a device is able to rejoin the network using a not secured request called insecure rejoin. So that's actually a Wireshark output. So this is the rejoin request. You get the rejoin response. And what's interesting is at the rejoin request is that the security level is set to false. This means there is no you need no secret data. You can just extract the necessary data for sending this request by sniffing the radio. So this means you just need the address of the target system and an address of what system you're trying to fake. So we see the security level there is false, and what you get is you trigger the key transport actually, and you see then in the Wireshark. So you see there what key is used for encrypting this message and what and decrypting in Wireshark. It's the default trust center link key. And the next one is the active network key our ZigBee network is using. So we can trigger this key response, which is very easy. So they also can't say anymore it's just limited to time frame. I can trigger it whenever I want. So it's very funny. So we need no physical access for this. We don't know any. We don't need any knowledge of a secret key, and usability overall security in this field. And we fully compromise the system because it doesn't apply net application level keys. So next step would then be, are we back on? Seems like. Then let me first play the video and then. So what we now do is open the door lock using the sniff key. Same setup again in the mid screen. You see the smartphone app. The green sign there is the state the door is locked. You see the bolt is in the door and you can't open it. So at the beginning I just open it and close it using the smartphone app. So you see it's orange, that's unlocked. You can open it. Then I lock it again using the smartphone app application, green, so it's closed again. Then I use our tool to inject the command. So you see, it's back open. You can open the device again. And what's very interesting is on the smartphone app and also on the cloud-based application, you won't notice this kind of change because it's not recognized. So you can, on the ZigBee level is not monitored at all. You can do whatever you want, you won't notice it. So maybe, I think we put the live demo part on the end if we have time. So what is the outcome of this? So at the first glance, the security level is sufficient. Yeah. So you first look at the door and think, okay, the security is pretty solid, but when you take a shift, you shift your perspective, you find some weak points how to easily enter and compromise the system. So this means the security measures provided are good in theory, but some requirements for end users, they say, weaken the security level drastically. So this means vendors only implement only the absolute minimum to be compliant to the ZigBee specification. They need to have a compliant system to sell it on the market. So it's a battle for market share out there, because besides ZigBee there is C-Wave. Now they're releasing, Google released a thread. There are really a lot of various wireless protocols out there, and they battle for market share. So what I want to take you out of this session, so the implementation of security measures is crucial, and compliance is not security. So that's the first point. We should learn, we all should learn from history, and don't make the same mistakes again and again. Like security by obscurity is a known weak practice, so don't rely on that. And there is a world beside TCP/IP. So, and what you can also do with a $300 door lock, it's also very surprising. We did physical assessment too. It's very, 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 very easy. Yeah. So, since we have a couple of minutes left, I think we try.
So you won't let us go faster.
Not really. If this would work. So, next try. But yes, so now it moves.
Your lock-picking skills.
So we need it on the other screen. More. Right. There it is. So it's a very pretty designed interface. So in the middle part, you see what devices got detected. So the 00, it's always the default address for your central router, and this is the one is our door lock. So what we now want to do is trigger the insecure rejoin first. So we have to select what. So it's funny, the menus get on this display. So we are trying to fake a rejoin from the door lock to the router. So we put the source, the door lock, and this destination, then the, yeah? No? Okay. Yeah, let's try. And then we just send the insecure rejoin. And we have to get it, so we make a couple of data requests. Insecure rejoin. Yeah. Yeah, data request. Ah, there it is. Yeah. So we also need now the Wireshark on this, on the other display. We didn't test multi-display support. So okay, we see exactly. Yeah. So back on top. This is our injected rejoin request, and we get the rejoin response from the router, And then we are doing an additional data request to just to collect the messages, and then we also get the transport key. Maybe just open it. Bottom. So we see that's our ZigBee device network key, and maybe we open the security header, then we see what key was applied to encrypt it. Florian? Yeah. Okay. Down. So you see that's the default key that was used for decrypting that stuff. So now we're also doing the command injection. So back to the ZigBee tool. Now we have to want to trigger a command from the ZigBee router to the key to the door lock. So we need to select a different source. We need to select the router as the source. Destinación, that's misspelled. So, okay, then it's locked, and no, the destination is fine. It's a programming mistake. So it's all relative to the source, and since the source has only one destination, it's 0 then. So this is okay. Yeah? Okay, I can't see the, because you need to inject it using the right counters, because there is a replay protection applied there. So we need to put a little more offset in it. Okay, maybe there is really a problem with the destination because it crashes. So I think we chose the wrong. Yeah. Okay. So, but with one display we are managed, so we can do it. So, okay. Then, thank you for your attention. If anybody is interested, we can show you it in a more relaxed way than later on if you're interested also in the features of the tool and how to handle it. So it's on GitHub, you can download it, it's free for everyone. Yeah. Okay. Any questions?
Question. You said you're using this in your home, right? So where do you live?
In Austria.
No, that was. I think you don't have the lock at your home.
Yeah.
Yeah. Further questions?
Yeah, but it's just applied to this small door. So in private, I don't use this stuff. So I also recommend to everybody think about what is your application of wireless stuff. So it's cool stuff. I like to playing around with it, but don't use it for critical systems like door locks or whatever it's critical to you.
Well, thanks for your presentation. My name is Daniel Sokola from Heise Media. Apart from hiring your company, what would you suggest ZigBee does now?
That's a good question. So I'm in constant communication with the ZigBee Alliance. They're releasing this year a new standard version, 3.0, and they try to fix some of these vulnerabilities. So they try to get rid of, for example, the insecure rejoin. So that's one of the most critical stuff because there is no real need for this command. So the user would have to do a normal rejoin procedure, which is, I think, quite common nowadays to do this. Also, for example, Wi-Fi routers are also using a sticker where there's an initial password on it, and you have to enter it in a system. You can also deliver, for example, the ZigBee lock, a sticker on it. Then there is a unique default key. You enter in your ZigBee router this default key, and you can exchange using this one-time token, your active network key. So they are aware of it, and they're trying to increase the security level. But their problem is they sold products to customers, and how to update the old products. And also, the new standard is somehow backwards compatible. So this means, that's an interesting point. But the reason why we talked in detail today about the insecure region is we are in discussions now for a long time with them, and it's most of the time you get some marketing responses and not really what they want to do, because they are not sure what is the best way to handle it. And I just want to mention, you can build secure ZigBee networks, but they are not certified then. You won't get a secure certified ZigBee network.
So this is for version 1.2?
This is for version 1.2, yeah. So also the application profiles are different. So we looked at the home automation profile and the light link profile because they're the most popular ones. The smart energy profile, for example, is very, very different. So they're using digital certificates for securing key exchange and that kind of stuff. So the security level is much higher there. So.
One last question? Nope? Okay, everybody's keen on coffee. Well then, thank you.
Thank you.
Thanks for the elaborate demo setup.